that you left the room. I'm taking back my life. All you did was use it. You break it, you lose it. Sorry, your time is up. Now I'm coming back to life. I'm taking back my life. Sorry, your time is up. Now I'm coming back to life. Now I'm coming back to life. You're too late, begging on the floor for me. I'm not the same. I'm standing on my own 2 feet. I'm taking back my life. All you did was use it. You break it, you lose it. Sorry, your time is up. Now I'm coming back to life. I'm taking back my love. Sorry, your time is up. Now I'm coming back to life.
Okay, well, now good afternoon, because I'm a professional and I know how to turn on audio. Normally it is Sahaj and I, but Sahaj is sadly indisposed. He will be with us for the second hour, though, is the current game plan. So we'll see what happens there. Let me see if I can get my chat window to come up so I can see what's going on, because at the moment I can't. All right, it says I'm connected to chat. Hopefully it is not lying to me. Cool. Yeah, it says that there's nobody here. So oh, good. All right, there's people. Hooray! I've done the right thing. So yes, we've got some stuff to talk about. Sahaj was going to work on some FPGA stuff, but like I said, he's going to be late. So instead, I was going to go through some of the odds and ends that are happening in news and whatnot. So let me pull up some things. We can figure out what's worth talking about. Let me pull up Pharonics from a couple days ago. There's a few things in here that are exciting. Also want to give you an update on what's happening with the RISC-V system, which is just now finishing booting, so we can go look at that. Let me go pull that up. We'll start there. Yeah, that's even the right way I want it. All right. So here, let's hop over there. The other fun thing is, if I did this correctly, we can actually listen to music on the stream, because I think I set it up right. Let's find out. The CPU's chugging along a little bit today. That's exciting. I've obviously done that wrong. All right. Theoretically, music will start. For those of you who are live. For those of you who are not live, we're going to be listening to Hybrid's new album, Black Halo, and I was trying to find a way of putting the information on the screen so you could see what track we're listening to, but that didn't work. So here we are. And also, it doesn't seem to be working at all. Oh no, there it goes. It figured it out. We have... everything's running the way it's supposed to. Amazing. Okay, so... Sci-Fi system that we were working on last week, it is actually up and running. It's not doing everything I want. And in fact, that's one of the things that we can try and work on here at the moment, is if I go grab the correct keyboard. Because I think I can see all of this. If I press this button, it's good enough. I have a window over here, I have a monitor over here I can look at as well, but it's kind of out of the way. Need this other mouse. All right. Now comes the fun part of me juggling between two mice and inevitably getting lost. Starting with, can I find the right input? Yes! Yes, I can. All right, good. Thanks, Kernel Console, for telling me that I pressed the right button. So part of the thing that I'm trying to fix on this system right now is I wanted to get Haiku installed. And let me know if the music is too loud. It might be. Pull it down some. There. That's probably better. All right. All right. Let me pop this thumb drive in. So the other update to give on the Hi-Fi system, which unfortunately I don't have a good way of showing, otherwise I would, is that I got the LEDs working correctly. So as it turns out, the Leonly fans do work with the NZXT controller that I had. The only problem was I didn't have the right cable. It came with the right cable. Speaking of cables, one is now sitting on top of the fan, which is great because I failed at cable management. There we go. Came with the right cable, I just didn't plug it in. Once I put in the correct adapter that it came with, plugged it into the NZXT controller, everything just worked. So now I have lovely white fans. The thing that Ed Belmedi put in chat last week for the adapter for the that Noctua fan that I have works great. So my temperatures are nice and low, as I can show by doing this. Yeah, as soon as I remember where it is. Class, thermal. Temp. So yeah, 47C on the CPU, which has been on for a little while and did a bunch of booting stuff, but it's fine. The machine is still slower than Sludge, and part of the reason for that is because it's still booting off the SD card. I haven't been able to get all of the bootloader stuff functioning with Eufy yet, but that's one of the things I wanted to work on today. The other thing I wanted to look at was well, that's fascinating. I guess I didn't put haiku on this. Or did it not load? Okay, let's go look at this. I thought this had gotta love UEFI. I don't know which one that is. Awesome. That's SDA. Print. This is obviously not haiku. Okay, well I did that wrong. That's fine. I think this is my FreeBSD installer, which also doesn't work. Something's very screwy with the EFI ecosystem on this board, and I don't know. I'm not sure what I need to do to fix it. I did make a couple posts, so I can actually show those. I did make some posts with what I have found thus far trying to boot on the sci-fi forums. See if I can pull that up while we're sitting here doing nothing. Yeah, here we go. All right. Press some buttons. We want Firefox. Wha-bam. All right. So there's this thread on the sci-fi forums called Booting with Grub, and some folks had figured out how to get all the Grub stuff up and working, and much thanks to them, I was able to follow this, figure out what patches needed to be involved, get the bits and pieces put together. There's actually, if we scroll down here to where I was, somebody has a lovely TechMan Ninja has a lovely, where did the rest of the posts go? Oh, there they are. Had put together a tree in GitHub with all the appropriate patches. So I went and used his thing with Grub. There's this lovely Fedora wiki page that explains what to do. Got it all up running, but it is very the unhappy. I can get everything to get to the point of booting at least, which is great. So this is a Debian kernel. You get all the standard messages, but the problem is we get down here, we get a whole bunch of things about it can't find controller clocks, and then nothing happens. It just sits here. All of this is in the initial RAM disk, so we've gotten to the point where the RAM disk is loading. It's in the right part of memory. We've appropriately decompressed it. Stuff is executed inside of the RAM disk. I think it's when it's actually trying to pivot over to the system that it's not working, but it's decidedly not happy. And similar story with Fedora, although with the Fedora kernel, we actually get a kernel bug, which is not great. Something to do with the memory mapping. Again, I am assuming that this has to do with the device tree stuff, but I'm not entirely sure. Systemd does come up at least, which is a bonus, but again, I get here and then nothing happens and I don't get consoles or anything. It's possible that in the Fedora one that it is working and I just need to turn on serial terminals, but at the same time, this does have a graphics card in it. The graphics card is supported. All the firmware for the graphics card, especially in Fedora, is there, but I did make sure that the firmware is there in the Debian image as well, because Debian's fun that way. Oh, and indeed, somebody finally responded to this thread. Oh, this is new and exciting. What does it say? It's saying the same thing. Yeah. Avoid systemd at all costs. Yeah, that's if only. Theological discussion for another day. Yeah. The funny part is, for those that don't know, systemd is a huge, and I mean huge, philosophical argument between the open source community. And the funny part is, everybody likes to point fingers at Red Hat and be like, this is all Red Hat's fault because they employ Leonard Pottering, and this is all his doing, and they just do whatever he say. Speaking as a former employee of Red Hat, the discussions on the internal mailing lists are just as divided as they are outside of Red Hat, so it's not that. I personally think there's a lot of benefit in systemd, but that said, that tremendous amount of benefit is kind of overreached. Like, Leonard had a blog, actually there was we could pull up this article because he had a blog post the other day talking about how cryptographic booting is ugly, and I was like, yes, it is. Yeah, so he wants to put together a whole thing with authenticated boot and the whole 9 yards, which he's put up in a blog post on his site, and I will link this in chat for the people who want to see it or read it later, because I'm not going to spend time reading it here, assuming that I used the right keyboard, which I didn't. And he has some interesting stuff in here. Like, to be fair, I wish Linux had significantly better support for Opal, OPAL, which is the built-in encryption that's on all of the modern SSDs, but it doesn't, and there's not a whole lot we can do about that. Part of that is, I think, because binary blobs and undocumented APIs, because I went down that path of like trying to see, hey, can I make this better? And there's very little information. BitLocker on Windows uses it, obviously. I think some of the big commercial tools like the McAfee PGP stuff, I think, uses Opal as well. But there does not seem to be a way to do it inside of Linux. I do agree with some of the things that he says in here. Like, specifically, a lot of people use the FS-crypt stuff. He also talks about how, we have to put the initial RAM disk in the kernel on an unencrypted partition, and that this is stupid. And I agree and disagree. Like, I agree that there is no authentication code and that no TPM measurements take place. And that's mainly because IMO, TPM measurements are a waste of time. If there was some way that you could sign the init-RD and then make sure that the init-RD is okay, which you can do with the TPM, but not easily. And the reason why it's not easily is because of the stupidity of the TPM. It's almost like 5 big tech companies got together and tried to put together a security standard, and that became the TPM. Oh wait, that's exactly what happened. So ideally, you would be able to load your own key into the TPM, and then when you do that, you could then make your kernel and your initial RAM disk signed by your key, and then if those images are not signed, Secure Boot would go, this is bad, and I'm not going to let you do it. But the reality is, actually implementing that is a hellscape of edge cases and corner cases and manual procedures that require like typing in keys. It's not fun at all. And heaven forbid you should ever want to do that on a machine that you dual boot with Windows, because oh my. So yes, there's definitely room for improvement here. I wholeheartedly agree that there is room for improvement here, and there should be room improvement here. I also don't think that like the stuff that our friends at Canonical are doing makes sense with their eCryptFS things, where basically your home directory is encrypted and nothing else, and that's done transparently. So yeah, hopefully someday it'll be better. I don't know how to make it better yet, at least in a broad sense. Some of the stuff that I'm working on for my hosting company, we are making it better but part of how we're doing that is making sure that images are signed and that there's verification with it and all that jazz. But we also control the bootloader, so that makes it easy. In a hosted environment, that's not such a huge deal, but in a everybody can run whatever they want environment, not so much. What other fun things do we have to talk about? Yes, there's a bunch of new stuff about Stream Deck that I am excited about. Specifically that the anti-cheat stuff is coming, which is good and bad. It's bad because easy anti-cheat is not great. It's good because it means a bunch of games will now come over because they have the thing that the giant studios want, which is the anti-cheat, anti-piracy stuff in place, which I'm excited about. The year of Linux on the desktop was still 1997. I'm glad that everybody else is catching up. BPF filter. This was cool. So, I gave a talk a couple years ago at, Rob Hirschfeld's DevOps dial-in thing, the name of which escapes me off the top of my head. I think it's recorded. It's probably on the Rack-N YouTube channel. But in any case, it was about the history of firewalls in Linux. For those of you who are as old as I am, back in the day we had PF, which was actually the same code base that was in BSD, and then that kind of fell apart. And then we had IP chains, and then we had IP tables, and recently we have finally all converged on NF tables. And I love NF tables. But at the same time that was happening, the new BPF stuff was occurring. So the irony here is that BPF stands for the Berkeley Packet Filter. This is the technology that is the basis for all the packet filtering inside of BSD land. Hi, all the BSD friends out there. We still love you. The Linux folks recently, specifically a lot of it with Greg from Netflix, who does a lot of performance monitoring stuff. Brendan Gregg, that's his name. He's formerly of Sun. If you were paying attention to monitoring like 10 years ago, you probably saw the glorious video, which is there a way I can pull this up without destroying the universe? Let me go see if I can find the clip. Let me see here. 1 second. Yes. So this is on. Again, I will post this link in chat, and I can also put it here because we're not actually going to get the audio, but that's fine. So we have this is from Brian Cantrell's Twitter. So that's Brendan. And basically what he's doing, he's working at Sun, and he's discovered that, hey, with all of these spinning Rust hard drives in the Sun servers using dtrace, that if you actually stand in front of the server and you shout at it, it will impact your performance. Negatively at that. So, like, here's your standard performance in the whole 9 yards, and in a second here he's going to go over and he's going to shout at the disks, and you're going to see the latency numbers jump all over the place. So, rack of old spinning Rust disks from back in the day, when Sun was an actual hardware company. And then he just shouts at them, which is hysterical. And then look, latency spikes all over the place. Like, it's brilliant, and all of this was made possible because of the joy of dtrace. So Brendan's been trying to get dtrace or something like it into the Linux kernel for a long time, since he left Oracle after the acquisition of Sun. He's now at Netflix, and he's been doing a lot of stuff with eBPF. eBPF is enhanced Berkeley Packet Filter, and it is used for a lot of measuring and tracing stuff inside of the Linux kernel, which is super cool. And Brendan's got a lot of great books about it. In fact, I just picked up another one of his. The reason why everybody's using BPF is because you can write pseudocode, or code actually, like C programs, that get compiled down into a BPF bytecode, and then that runs in a just-in-time virtual machine inside of the kernel. It's a very small set of instructions, which is lovely. And it's also very memory constrained. Like, you do not have a heap. You have a stack, and you have like a maximum of 4K of memory. So it's really designed for real-time applications, and then it's very easy to pass data in and out of the kernel and in user space. So there's a lot of stuff for performance monitoring with it. But you can also do packet filtering, which is what it was originally built for. And now the circle has come all the way back around, and there's a lot of talk of like, hey, why don't we build a packet filtering thing on top of the packet filtering code that we should have used 20 years ago, and instead went and did our own thing and then made a different virtual machine inside of the kernel called NetFilter, and now we're talking about changing that back end out to be BPF based, because as you can see here, it's much faster. So, yay! I don't know. We'll see. I'm excited. Anything to get the firewall stuff better always makes me happy, especially since we kind of left IP tables in the dust with gigabit networking. NF tables seems to be good for 10 gig. I don't think it's good enough for 100 gig. And anything I can do to prevent traditional network vendors from having routers and firewalls in the core of my high-speed network, the happier I am. So that was kind of fun. What other fun stuff? A couple regression fixes in 5.15, which is always exciting. FTP support is now gone in all of the major browsers. I'm sad and not sad at the same time. Hopefully some of the people who had stuff that was on FTP only, there will be reasonable HTTP mirrors for it. Otherwise, FileZilla is still available. Michael did a whole bit here on the High Five Unmatched. This should look familiar from last 2 weeks ago. And lo and behold, the performance is not great when compared to the Raspberry Pi. Who would have thunk it? Honestly, we kind of all saw this coming. It's not really a big deal. He is running the tests on the Ubuntu release that will let you run off of the NVMe drive. So it's not as I/O constrained as the stuff that I'm currently running, which is just the base image that's running the open embedded build. And that's cool. But still, it's not spectacular, and this isn't to be surprising at all. There's been very little optimization done in this ecosystem so far, not because of anything other than lack of hardware and dev resources. This is the same thing that Sahaj and I will be happy to talk about, that we dealt with the ARM ecosystem for years. The good news is that part of the reason that this board exists is to make these charts look better over time. So now that you can go buy a machine with 4 cores and 16 gig of RAM that runs an actual graphics card for under $1,000 in a standard PC form factor is really going to help make the stuff better in the Linux ecosystem. The next step would be making these available in some sort of hosting or cloud environment. Gee, I wonder who could work on that. And yes, it is something that we want to do. We were very excited to do stuff with the Beagle 5, but then that project got canceled, and it's possible there may be a replacement coming out. Watch their space, and depending on how fast things go with the hosting stuff that I'm working on, watch that space. But yes, I do want to get a bunch of these up and running, and I want to make them available for people who don't have the $1,000 to go spend on one of these, because the board's $600, and then you got to put a couple $100 worth of peripherals on it. But if you are working on core infrastructure stuff and you are interested in getting your hands on a RISC-V system to do compiling and testing and whatnot, please reach out. I'm happy to try and set you up. I can get you onto this machine sitting here next to me really easily. Hopefully we will have more hardware soon. There's also initiatives in the RISC-V Foundation to get boards to people. But yes, the entire I gotta go find the wonderful graphic that was about curl, but doesn't matter. Here it is. good job. So this graphic, we'll reuse this thing. This is an XKCD joke about curl and image magic, which is absolutely true. Like, all modern infrastructure depends on it. Some guy has been thanklessly maintaining it since 2003. Actually, I think there's another version of this that Daniel from Curl has, where it's a slightly different date, and it's a guy in Sweden because that's where he's from. But same thing. The internet is built on open source software. Most people don't realize it. It's all done by people in their spare time as a hobby. And, you know, thank you for doing all of that work to all of you who do it. And if you need help, please ask, because we want to make it better. More Rust things happening. I don't know how I feel about Rust modules in Grub, but more Rust things, so yay. And then another anti-cheat, anti-piracy thing coming to Steam Deck and Proton. Again, all good news. Like, at some point, we're going to have an anti-cheat system that's going to require lighting a proprietary kernel module, and at that point, we'll push back. But for right now, cool. Let's keep moving forward. Let's see, what other fun stuff do we have? New version of OpenCFS, which is always a welcomed and excited thing. Intel's making interrupts faster with their new processors. Amazing. Cool. That's kind of what's going on there. I have another 30 minutes to kill. Okay. Let's do my other favorite thing and scroll through CNX software. See what other new and exciting ARM and RISC-V and SBC hardware is out there worth playing with. Ooh. Stackable power meters. That's nifty. Let's take a peek at that. Oh. Fancy. Oh. Wi-Fi. Oh. Okay, well, and it's only 2.4 Wi-Fi, because of course it is. But it'll do 485, so that's decent. Okay. I'm going to guess that these things are ridiculously expensive because it's... Oh! Wow! I'm thoroughly impressed. That's like downright affordable. Okay, cool. So if you need to switch a bunch of power on stuff, there's a good way to do it instead of having to do what I've done and build it from scratch. Ooh! That's pretty cool. 2 network ports and everything. Use a Xavier or a Nano as a router? Fascinating. And of course you can plug like 6 cameras into it because of course you can. That's pretty cool. And you can put a reasonable number of hard drives on it. 5 SATA ports. That's excellent. Okay. So yeah, if you want to like build a NAS or a router, this seems reasonable. And because you're running a Jetson Nano or a Xavier on it, you could like run Plex and actually have it do transcoding. Cool. RK3566 platform. What else we got? 802.11 AH. Hey, what is AH? Oh. Why would I want to run Wi-Fi in 900 megahertz? Please no. Okay. I did actually back this at the level where I get the whole kit with the fancy case, so I'm looking forward to getting one of these, and we'll probably play with them on the stream when they show up, whenever they show up. So that's exciting. For those that don't know what this is, the PiKVM3 is this cool little project that kind of looks like this, which looks messy, and it is. But it basically lets you plug the Pi with this hat on top of it into another machine and control it remotely. You get this lovely web interface. You get the full video output, virtual keyboard, the whole 9 yards. You can power it on and off remotely. You can press the reset button. It's pretty cool. I'm probably going to use a couple of these at work for some projects that we have coming up. But in the meantime, I figured I'd pick one up while I could. We'll see how that goes. We can probably make half of the ads on this page go away. Raspberry Pi 3 mini board. Interesting. Is this a... Oh, that's odd. So this is a Raspberry Pi 4 compute module, and and that's a Pi 0, and this is whatever this crazy new Raspberry Pi customization program from Element 14. Custom Pi 3 SBCs. Huh. Fascinating. Sadly, it's only got the 1 gig of RAM, but I mean, you know, on the Pi 3 you are kind of limited. More modules with the IMX88 Plus. Okay, cool. Someday I will learn how to use GStreamer. Probably not this decade. Oh. Rack mount for Xavier's and Nanos. That's cool. Although it looks like it's just using the standard carrier board, which is a little big, but that's okay. Oh boy, stuff using Amazon Sidewalk. Ugh. Jasper Lake, that's a Celeron. Boring. I have one of these. I'm curious if anyone's ever going to do anything interesting with it, because it's basically a giant FPGA embedded development platform. Like, I was hoping to be able to run Linux on it, and it's so bad, which is unfortunate. But it's okay. We have the high five unmatched, and I'm really happy about that right now. So, ooh, a fancy Home Assistant thing. It's got a Zigbee module in it. Neat. M.2 Raspberry Pi 4 gigabit Ethernet with PoE and a Zigbee module. It's not bad. So I've been slowly putting together stuff for a home automation project, and I'm not sure how much of it is going to be net new and how much of it is just going to be building plugins and stuff on top of Home Assistant, because it had been so long since I had looked at Home Assistant. When I started looking at it this time around, I was like, this has come a long way, and I really like it. It has still got a learning cliff. Not quite the EVE Online learning cliff, but pretty substantial. So I think what I'm going to wind up doing is use that as the basis, because it basically already talks to everything I want it to, with a couple exceptions. But writing plugins for that and making them available, and then building some UI blocks on top seems reasonable. ESP32 things. Actually, I am interested in an ESP32 with a LED on it. Yep. $7. Awesome. Okay. $2 over the, okay. This might actually solve a problem for a meeting I'm having later this afternoon. Cool. I can see some people in chat, apparently, maybe, looks like, yeah. So if anybody's got questions or things that they want to talk about, please feel free to ask. Otherwise, I'm just going to sit here and ramble until Sahaj shows up. What else we got? if you have not seen these new full color, I think it's only 7 color, but with the 7 colors you can basically get full color e-ink displays. They're awesome. They're pricey as all get out, but they're hot. I mean, I don't know how much of these screenshots, actually those don't look like that made up, but yeah, these new e-ink displays are pretty cool. I like them a lot. I'm hoping that these are going to come in at $170? Oh, that's not bad at all. Oh, $260 for the big one though. Yeah. Okay, well, still $170 for a 6-inch display, and it's based on Pine 64? Okay. 3566, quad-core A55. I mean, nothing exciting to write home about, but at the same time in an e-reader, that's freaking overkill. 150 ppi for color, 300 ppi for black and white. That's awesome. You could do some fun things with that. I think I saw yesterday that Waveshare actually sells these displays if you want to just go dive right into buying the displays. I was looking for e-ink displays for work and found some of that. New Tinker boards. RK30 399 OP1. Okay, cool. 4 gig RAM, which is probably, that's probably 4 gig on the RK3399, and then there's probably some additional RAM for the OP1, which is the neural networking stuff that's jammed on the side. That's usually how those work. A lot of times these come up and they say that there's 6 gig of RAM, and then we look at the spec sheet and go, oh wait, no. This might actually say 2 gig or 4 gig. Okay, so that's the primary difference, and I'm going to bet the 4 gig one is like outrageously expensive. Does not say. Okay. Cool. I don't know if that would be worth supporting in our hosting environment or not. It's not really super compelling with only 2 A72s and only 4 gig of RAM, unless you really want to do neural networking stuff or ML stuff, but I don't know. Make a survey on it. So for those of you in the hardware world, the Scilab CP2104 has been it's in its first stage of discontinuance. There are a lot of replacements. This one is literally a drop-in, which is cool. The CH parts are okay. There's also the new Neo Serial 2 from Scilabs, which are sadly not pin compatible, but have I think it's like a 10 plus year support cycle on them. And I know Desk of Lady Ada did a whole thing on this a couple weeks ago, and she's planning on switching to those instead of the CP2104s. So FYI. The other advantage of I think the primary reason why she did that instead of the CH part was because the CH parts were hard to get their hands on, and I don't think oh no, they do go up to multi-megabit, which is good. That's needed for a lot of the Arduino stuff. Some of that stuff operates at like 2 to 4 megabits. I'm sorry, what? USB-C video out? Wow. I didn't know you could get USB-C video out on an Arduino Pro. That's cool and terrifying. Okay. Another 3399 board. There's so many of them. Lots of Bluetooth vulnerabilities, so it must be a day that ends in Y. A Russian 32-bit RISC-V MCU. Okay. Really? You couldn't spring for putting the atomic extension in? Oh, Russia. Okay, fine. Interesting nonetheless. Spiffy. SB32C3. I believe. No, the C3 has the RISC-V processor in it, as opposed to the Extensa core. So that's cool. How much? 4 mega flash. Wow, that's nice. How much are these things going for? $288 plus shipping. Not bad at all. Okay. Interesting. The RISC-V microcontrollers on these operate at 160 megahertz, and they have 400K of SRAM, which is awesome. I think the thing that it is missing, though, yes, it does not have native USB. Otherwise, everybody would be buying these up by the truckload. That was a bit of a missed opportunity there by Espressif, but that's fine, because with that much RAM, you can run CircuitPython no problem, or MicroPython for that matter. But without having the native USB, you have to put on so many extra components, and the bootloader becomes such a nightmare. It's, yeah, unfortunate, but hopefully they will fix it in the next release of that product. Sci-Fi bought a USB IP company, so I'm hoping that they're going to be able to make inexpensive USB OTG IP available in the marketplace, so that folks can integrate that, but I'm not sure. The OpenSSL 3 stuff is interesting, that they finally made it fully modular, and now the MIPS portion of it is an actual pluggable engine, which means that you can actually just add it to it. What extension was that? Oh, in the Russian RISC-V thing. I'm sorry, I'm not paying close enough attention to chat, and I should be. The A is atomic memory operations. So that basically means you can make sure that whatever you're doing, you're the only person doing it to that section of memory, which is relatively important. Most of the other microcontrollers do implement it. You can know this because when you look at the instruction, it'll be RV32 IMAC, which means it has integer, multiply and divide, atomic memory, and compressed instructions. They left the A out, which is unfortunate, but I'm sure they had good reason. Cool. I have some messages. Oh, let's see here. Oh, right. David W., who was on, but apparently is having difficulty getting the chat to work, so sorry about that, wanted to remind me about this thing. So, Ampere COM HPC modules supposedly available to mere mortals, and by mere mortals I mean people who have $15,000 to $20,000 lying around. It's certainly interesting. It's going to make stuff, because, like, look at this thing, like 32 to 80 ARM cores. Like, that is ridiculous. But like I said, also ridiculous price point. This is basically designed to be a platform for doing development for autonomous vehicles. But interesting nonetheless. Kind of reinforces the thing that I've been saying after the Apple ARM thing occurred, which is, unfortunately, Apple making their platform ARM-based has really solidified Apple to be for the expensive toys only. This is a standards-based platform, because all of the Ampere stuff is, but, like, you will notice that this document talks nothing about pricing and availability, and that's always been the problem. Like, Ampere makes wonderful stuff, but, like, trying to buy it is a nightmare. And also, it's only ARM v8. Whereas if you were to go buy even last year's mid-tier SoC from Qualcomm that's already at 8.4, and there's a lot of stuff that the kernel, the ARM kernel, Linux kernel development people want that's in 8.4 or later, and now we have ARM v9, and the server stuff is so far behind at this point, because it's so expensive. So yeah, I don't know. Hopefully that will get better, or we just find a completely different way of getting ARM servers into the market, which is not waiting for people to make giant standards compliant server ready platforms, because it just doesn't happen. Or at least not at a reasonable cadence. So only so much we can do about that. Let's see here. What other fun things can we talk about? I have no idea. Yeah, I don't. I guess what I should have been doing while we were sitting here this whole time is actually imaging Haiku back onto the system. That would have been smart of me, but I did not do that. So maybe I'll do that now. Oh, I think I can perform some minor magic and make this work in a reasonable way. First off, let's see if I can get this to wake back up. I can. Good. All right. All right. Watch as I perform heresy. All right. So we need to get a file that's on my other computer. Yep. Sure, you can update that. I really need to move this over to, no, it's not there. Source, RISC-V64, did I put it here? I did not. Okay, do I have the Haiku thing? No, I don't have the Haiku thing. Okay, well that was fun and exciting and didn't last long. Let's see if I can go get it. Give me 1 second. I don't want to compile it. I want to download one of the images that already exists. Aha! I think this is it. Yes. This version is revision 3. Good. There's 3 releases. One of them is revision 3. Hey, that's the one, and that has the file. Oh, that's not as bad as I thought it was. It's only 100 MB. Alright. Give me thumb drive. Hopefully this will not cause the computer to have a complete seizure if I re-image this. No. Do not format the disk. I don't care. I don't care. Did it finish downloading? It did. IQ image, extract that there. All right. Fine, show me all the files. And sort by name, because yes. Oh goodness. Windows, why? Just why? Alright, here comes the fun part. how angry is the computer going to get? Very. Oh dear. Oh dear. Oh good. It's moving at a reasonable clip. Okay. I think things are getting better. The USB bus is not happy. This poor computer. Probably should have found some other way of flashing this image, but whatever. It's happened. In 5 seconds, we can forget this ever happened. Alright, hopefully Windows has not completely corrupted this stupid image. Alright, so, that's toasty. Alright, and plug this back in. There we go. And then I should be able to that's fine. Let's go look at this. Aha! Haiku Risk 5 is what the partition name needs to be. Okay. So if I am especially smart, I think I've already copied over the yeah, I've already copied over the actual partition, but the way the bootloader works is that it looks for that particular name. So let's see if we can rename the partition in a way that makes sense. To, what is that, 6? Okay. How do I change the name though? Oh, it's just name. Six. Cool. All right. So with that done, we're now going to try and reboot, which may or may not work. Sometimes it does, sometimes it doesn't. But with the Haiku stick in there, it should now be able to detect the Haiku. Are you going to boot? Let's find out. It should be able to find it on the NVMe drive. For whatever reason, it was not able to find it on the USB stick before. I'm going to blame that on Windows messing with the partition table, but I'm hoping that it'll find it on the NVMe drive. We'll find out in a second. Yep, that's all good. Okay, yes. It's looking for devices. It found devices. Oh. That is looking. It found the right boot device. I need another keyboard. Actually, I can do this from here. I'm excited. Alright, video mode is set to none, so that ought to be entertaining. That's the one I want. Continue booting. Okay. That's fascinating. I've never booted this operating system before, so Okay, this is something. Something is occurring. It's looking at the NVMe device manager. It's finding things. Something has occurred. I think it's saying that it found the graphics card. Holy cow! It's Haiku! Oh, man! Okay, so this is actually kind of cool. Let's talk about Haiku for a moment. Haiku started its life as a piece of software known as BOS, B-E-O-S. BOS was supposed to be, supposed to be is the wrong word. BOS was one of the things that was going to be Mac OS 10. Or 8, excuse me, not even 10, 8. And so I saw demos of BOS at Macworld in like 1997, and it would blow your mind. Like, it had, first off, it supported dual processor, which was a thing that was just unheard of in the time period. Very few things had multi-processor systems, but this, I think, was the BOS developer platform, which I should go look up the hardware specs on that, because it's a fascinating piece of hardware. That's not what I want. Show me the machine. BOS applications. No, that's not what I want. So, where is a picture of the thing? Power using classic Mac OS, blah, blah, blah. So, it was a dual processor machine. I want to say it was like a 601, maybe a 604, which, I mean, these are old processors. I'm sure nobody knows what any of those things are, and that's fine. Aha! The B-Box. Yes! Here it is. Okay. So, this is... Let me switch the screen so you can see what this looks like. This is the B-Box. So it does not look like much, but there is some awesome things here that are worth pointing out. First off, these stacks of LED lights in the front of it, those are CPU monitors that are actually driven by the hardware. It had 2 PowerPC processors in it. In fact, I think we can zoom in and we can actually see which one it is. This is a 602E. So, had 2 602Es in it. What was just astounding at the time, remember, 1997. So this machine didn't have a lot of memory in it. I think this will actually tell us what it had. It supported 8 72-pin SIMs, so we're probably talking somewhere in the order of 20 meg of RAM. Had all of this other fun stuff. The back of it was interesting because it had this thing called the Geek port, which you could plug in and do all sorts of wonderful stuff with. But the demo that they were showing was it had 2 of these 603 processors in it, and it had 24 QuickTime videos running, decoding in software in real time, mixing all of the audio together and playing it in 1997, which was just wild. So yeah, it was cool. We were all very sad when the folks at B didn't make the cut, and because of that, they did not make it back in. They were not chosen for Mac OS 8, but it lives on. The actual history of BOS after that is fascinating. It involves like being bought by Palm and used by various other people, and bits and pieces of it are actually loaded into like LG television sets now. it's wild, but it was eventually, parts of it were released as open source, and the Haiku project kind of picked it up and ran with it from there. And a couple crazy folks, or one crazy folk, I should say, at the Haiku project has actually made it work on this RISC-V machine, and now we can see it in all of its glory and wonder. I don't know what apps we have. I mean, that's a great question. Probably not a lot. There might be a web browser in here somewhere. Oh, we can look at the disk usage. Yes! So the reason why there's two Haiku RISC-Vs is because it's actually, it can see the hard drive and it can see the one that's on the SD card that I have plugged in, but that's fine. Expander. Oh, is that, oh, that's just compression, decompression utility. Okay. The media player, process controller. Okay, that's great. There's a process controller already running. Oh, hey! We can get a nice little CPU chart that I cannot make bigger. That's fun. It's probably hiding over here somewhere. Yeah, there it is. Neat. I think, yeah, let's run the about. 1 gigahertz processor. It sees all 16 gig of RAM. It's only using 500 meg. That's awesome. Been running for 7 minutes. Wonderful. This is very exciting. A non-Linux operating system running on my Hi-Fi board. This is great. Ooh. I'm going to guess that's also sitting over there. What happens if I click on this and I'm like, hey, oh, can I actually configure the network? DNS settings. That's totally wrong. Okay. Interesting. Is there a command prompt? Yeah, there's no audio things plugged into this, so that doesn't surprise me. I don't remember how to pull up a terminal. I think this is the Process Explorer, which is obviously not working. But that's fine. Yep, that's certainly a thing. We can run system tests. That's always a good time. Not really. Cool. All right. I think Sahaj is here. We can actually try and pull him in here in a second. He doesn't have his camera on, though, so we'll try and fix that. There he goes. All right. Let me push some buttons. Copy link. Come over here. I just need to adjust this. Properties. Boom. If I've done that right, which I haven't. Oh, I have! Hey, there he is. Can you hear me? I don't know if you can. Let me fix that. Hello, Sahaj.
There you are.
Oh, I can't hear you. All right, so I've done something wrong. Let me see if I can figure that out.
Oh.
I probably just need to monitor you. First off, do I have you on all the right channels? I do. That's good. You are set to monitor, so I should be able to hear you, but for whatever reason I can't, and I'm going to say that is a me problem and not a you problem. Hang on. You need to find where you're coming through my incredibly complicated audio mixer. We have music this week, because I figured out how to make that work. I don't know if you can hear it, but we've been listening to Hybrid's new album, and in fact we're on the last track, which is perfect because I specifically picked this because it was only going to last an hour. So timing is excellent. Also, Haiku running on the Sci-Fi board, which is exciting.
Oh, I saw.
How can I hear you? What if I do that? What happens if you talk now? Can I hear you now?
Hello.
I guess not. All right.
Hello, hello.
I'm still looking somewhere here. That's muted. Can I hear you now?
Hello, hello.
Hey, I can hear you now, and hopefully we're not
Yay.
causing double audio.
Um, I hope not. Can you hear yourself from my mic?
No.
Okay, then that's good. I've moved over from using headphones to using proper speakers.
Spiffy.
Um,
And
yeah.
we can.
Uh, what else?
I mean,
Right.
let me push some buttons.
I
Hang on a
saw the
second.
haiku stuff,
Yeah, I'm excited about
and I'm
that.
I'm jealous because haiku doesn't run that well on ARM.
No, I don't think it does. It probably runs that well on
No, no.
x86, but it does not run that well on
It
ARM.
it runs that well on some x86, and sadly the laptop does run that well on, including Wi-Fi. Is my mom's current laptop because she took my old one, and that has excellent support. I've not yet found a proper hardware. I'm willing to bet something runs on the P4 behind me, but that'll be a wild guess. Maybe the code to do has some, uses, but I don't think that's it. So I don't have that many hardware that can run Haiku that do run Haiku that would, because I've tried on all of them.
Yeah,
So that's why I'm kind of jealous because I've always liked that OS for whatever reason. Like I don't even have a history with like the BOS or that era, but for some reason just felt fast.
yeah, yep. Haiku is really interesting, and I'm very excited that I get to tinker with it a little bit. We did have double audio. I think I just fixed it. That was a routing error on my side. I'm sorry, but I think it's all good now. Awesome. Okay. Cool. All right. So we've got 46 minutes. What did you want to do? I've been stalling for time. We just to recap, like we went through and we talked about a bunch of stuff on Phoronix, or which is to say, I rambled on a bunch of stuff in Phoronix. I did have one question about what are the various extensions in RISC-V, so we got that fixed. I can actually see chat this week, which is great. That was not the case last week. We looked at some various odds and ends on CNXSoft. We listened to this awesome album from Hybrid, which is now over. We got Haiku working on the RISC-V system, which wasn't that bad, except for the point where I had to actually image it back onto a USB drive and completely made the computer angry for streaming. But we got over it. So yeah, what do you got?
I was planning on doing some FPGA stuff.
Okay.
And now I'm just confused how to make my VS Code's text bigger. Some reason it's not the simplest thing in the world.
Okay.
Oh, there you go.
I apparently need to. All right. Let me
So I think I can
put a couple
go
things in here.
through bits of it and actually explain the main logic, start to code some, and we'll see how it goes.
Okay. Give me 1 second here. I'm flipping some
Ooh.
bits to make a new and
We'll
exciting
be
thing.
we'll be doing a lot of bit flips. It's an FPG. It's all about flipping bits.
It is. And then if I now go in here and I add this on, I think it's port 1. Nope, I am wrong. It's fine. It's fine. Port 2 is my camera. And so I should now be able to take this, shrink it, and throw it in the corner, and then do that. And we should all still be able to talk to each other and fun stuff like that. And I can hear you, and I might even be able to do fun stuff of like make most of my background disappear. So I'll work on that while.
So I'm not passing stuff through OBS.
Uh-oh. What do I have to do then? Or what
So
do you need from me? Let's put it that way.
I'm just sharing my screen. Not sure how it shows up on your end. So you have to put that up.
Let's find it. Oh, there it is. Oh. All right, hang on. I know how to fix this. I want to go find the same thing that I just had, which would be this, and I want to duplicate it. One moment.
Why does the screen share shows up as near replicant?
Yeah, it shows up as its own thing, which is fine.
No. Like it shows up as a game icon.
Well, yeah, that's not surprising.
Hey, KD.
Okay, and then, what's the resolution of the screen that you're sharing?
Oh, that might be an issue. It's 21:9. 2560 by 1080.
2560 by 1080. Okay, that's actually fine. It just gives me something to work with so that I can attempt to scale. Hey, look, it's scaled. All right, so now we can take this out. Live adjustments. I think I'm going to move us up onto the top, or no, I don't know. Top at the bottom. I'll probably put us on the bottom. I'll see if I can make this fit. Oh, that's so much better. Okay, that goes there. You go here. I go there. Ship it. Boom.
It'll take a few. Oh, there it is. Not too bad. Not too bad.
It's not bad at all. No, it looks totally readable.
Yeah. All right. So,
all right, I'm gonna go find some music.
Yeah, what we are working with is Govin FPGA. It's a $5 FPGA board that's based on a very, very cheap Govin FPGA part, and it's mainly built to run like these RGB LCDs. So you can see the strip there for the LCD interface. This thing costs $5. So what I want to do is we've had an issue in one of my projects where the way a Hall effect motor works, a Hall effect sensor. So let me just quickly search the any sort of diagram or anything that we can find. So we are solving a problem of a Hall effect encoder to
this
get.
Is for your drone, right?
Yeah, this is for my car project.
Car. Sorry. So for those who don't know, Hall effect is you have a magnet that goes past a sensor, and you can basically count revolutions on something without having a direct connection to it.
Yeah, so you have a magnet here and you have a couple of sensors on the edges. And when the magnet is weirdly magnetized, so it's not a north up south down thing, it's divided into four quadrants. So every time it
Yep.
moves, it creates a waveform. Now usually the stepping between the poles is quite large, so you get like 6 to 7 waveforms per rotation. But the problem happens when you start gearing the motor, and when I gear the motor to about 1,000 RPM, it's a 10 to 1 ratio. So, and
Mm.
every RPM it's sending out one high and one low interrupt on
Oh.
two separate Hall effect sensors. So it makes up for a
Ooh.
lot of
That is a
interrupts. That
that's a
it's a
lot of interrupt
ton.
traffic. That's
Yeah.
probably like
So
3 cores worth of interrupt traffic.
yeah, so what people usually do is to have something like a Arduino per motor and have that connected over I squared C. You still can't have very complicated I squared C logic, but at least you are able to sort of have the I squared C interrupt at a higher priority than the GPIO interrupt, so you can do basic stuff. The problem is that even Arduino only has two interrupt lines, so it can handle one motor, and then for four motors, you need four Arduinos. So that's what I am trying to like do with the FPGA, is to just make one little logic and then sort of copy it 4 times, so that it just creates four different um, for four different logic connected to one single I squared C. So I can just go I squared C request data from register A, gives me the timing. I'm not doing any complicated math. I just need timing between two pulses. Just give me the timing between pulse A and pulse B, and then and then I squared C take me to register B, give me data from register C and D. Similarly, and so there's no interrupt involved in an FPGA. There are four separate logic. They're writing to four separate registers. Only the I squared C bit is common, and all it has to do is sit there and read the latest data from whatever register. So we are sort of nulling out the PID in a over polling manner. So I'm not expecting to hit the I squared C data so much, but the update rate from the from the Hall effect sensor is going to much higher. So that is what we are doing, and the logic is super simple. Um, Actually, all of these are three phase for some reason. Let's see if we find a good one. Uh, so they are offset by 90 degrees. So you have A waveform and we have B waveform. These are
Okay.
offset by 90 degrees. So you can basically get the direction. So if waveform triggers first, then it's in the reverse direction. If A waveform triggers first, then it's the forward direction. That's sort of the stuff I'll want to um, deal with later on. But first, I just need to like pick just the A waveform and then start getting timing off of that, and then we'll see the A B difference thing. So I think this is a much better diagram here.
Ah, quadrature encoding.
Yeah.
I have to deal with this all the time in retro computing stuff because that's how all the mice work.
Um, yeah, basically A and B. So this is exactly what I was talking about. Clockwise is A first, B later. Counterclockwise is B first, A later. But we are not. We eventually do want to take into consideration the direction, but for now we are just dealing with um, the spinniness of it. So our logic is simple. We start with once we detect a trigger high, we start counting, and once we detect a trigger low, we stop that counter, and we can either do at every high position, or we can count both high and low. That's fine as well. um, the
Okay.
way the way my motors are set up, and this thing is going to be quite focused on what my setup is I have um, a motor that does 70 interrupts uh, for one full rotation. So
Okay.
it goes one up, one down, that's two interrupts, and then one up, one down. So that follows that 70 times. So we'll just hook on to the state change. The other problem arises is, yes, of course, after every state change, we do clear out the counter, but then when does what's the maximum length we want to go? And I'm saying that if it does 70 um, 70 interrupts every rotation, it goes to around 0.800 milliseconds max, or so. And after that, it goes to the sub 1 RPM level. So we'll just, for my use case, I'll just ignore the sub 1 RPM level and make our registers large enough to have 800 milliseconds or something like that in the buffer. And we'll add a divider to just tick every millisecond. That should be easy to track.
If you say so. This is my first time working with FPGA stuff,
Mhm.
so I'm gonna defer to your expertise.
What else did you have in mind?
No, no, this is fine. I've just seems perfectly reasonable. I like I said, I don't know how to do any of these things, so it's all good.
It might take me a while as well to get the basics sorted up because I've not touched an FPGA in a bit, but oh well, we'll get into the mode of FPGA programming. One more
Yeah.
sort of quirk with this particular FPGA is the write flash function doesn't really happen right now, so we are limited to SRAM. This is either being debugged or something, and if the flash functionality doesn't really work out, then I might just switch over to another FPGA. The logic, the code remains the same, just minor things that we need to change.
Okay.
Okay.
So, out
Um,
of curiosity, on this particular FPGA, what are like? Do you have a link to the actual part?
yeah, I'll just post that. It's called the Sci-P Stang Nano from Seed Studio. Oh, they just sell it. But yeah, very tiny FPGA, like 1,000 odd lots. Just
Oh
six
wow, that
dollars
is
long.
tiny.
Yeah.
Only a
So at least
thousand
it's
lots.
as
Wow.
much as the lattice ice stick,
Okay.
which is like the previous most beginner friendly FPGA to work on, and it's a tad bit
Sure.
expensive. So this is a good change. Yeah, this
Yeah.
has
Yeah.
1,000 lots as well.
Okay. Yeah, I know. I've met the guy who is responsible for all of the marketing for uh, Go In,
Yeah.
and it was funny talking to him because he was saying how like yeah the our FPGAs are so cheap it usually costs more to ship them than to make them. So he was trying to find ways of making it easier for people to get them because he's spending so much money on shipping.
So the other
Hashtag
good part,
hardware problems.
yeah. The other good part is that this thing is completely upstreamed and reverse engineered. Of course, the Govin didn't do it themselves, as it did for
Right.
most FPGA vendors. It runs on YOSIS, does the placing from using Next PNR, and then the whole project for this FPGA is called Apicula. I think that's the pronunciation. And then it flashes. Oh, I have the main flash on, not something I wanted to do.
Can
Give me a
you
second. It
post
will
some
never
links to
work.
some of these things? Because it doesn't look like they're
Yep.
linked on that product page, unfortunately.
Yep. Give me a
Why, it looks
second.
like it's flashing now.
Oh, it's flashing to the main flash, and that never works. It fails at the end, so I have to change that. Yeah, remove this flash to SRAM. Uh, the SRAM flash is usually much quicker. Yeah, see,
Seemingly, yes.
I have reduced the JTAG speed to 500 kilohertz.
Okay.
It's usually 6 megahertz, and I reduced this in the code
Ooh.
just to debug the flash issue, and it doesn't seem to be JTAG speed based. It's something that even the folks who wrote the JTAG driver for this chip haven't figured out. So, eek. Hey, reverse
The
engineered
great thing
code.
about JTAG is how it isn't a standard at all.
It's a standard in its name. Everyone uses the same
Yeah.
name. I don't know if everyone even uses the same full form.
No, like different footprints, different. Like the protocol is sometimes the same. Yeah, this is something that I've been dealing with at work because we're trying to bring all this stuff up in JTAG, and our ODM is all like, "Oh yes, please use JTAG," and we're like, "Which one?" Like we're using parts from 5 different vendors. But before you dive too deep on that, I wanted to see if we could get the links to the software stack you're using.
Oh yeah.
That would be helpful. At least this way we can like put it in the show notes if and when we can never get this stupid thing to let us upload to YouTube.
Yep, there you go.
Cool. Neat.
So what I'll do is I'll take the reset key as a sam as an input, or like the key as an input. Um, and the simpler part would be to just blink an LED, have a 1 bit register, blink an LED, start from there. Um,
Okay.
so go. It's been a while. It's like I have to reference everything.
So it looks like this software stack lets you do the. Okay,
It
so
lets
this
you
is
do.
just for.
Yeah. So you take your Verilog, you run it through YOSys to get the JS stuff,
Got it.
and then that goes into next PNR, specifically the
And then that
apicula bit.
spits out the bit stream.
Yeah, that spits out the bit stream, does your all the wire routing and everything
Okay, and
internally.
Yosys is a Verilog synthesizer. Okay, cool.
Yeah.
I understand now. I actually want to go look up like what parts Yosys supports. Command reference.
Just bring that over wire instead.
Ha.
Then go from flag is
So Yossis can synthesize ICE 40, Xilinx 7, Silico Green Pack 4, which I've never heard of, and a whole bunch of GoWin devices. Two different series, GoWin 1N and 2A. Neat.
so we'll go just one LED. It has three colors, so we'll just track one, and then we assign that to flag wire. I think I can assign it to a wire. If not, we'll need to assign it to a register. That's small change. Make prog synthesis error. Great. How do I do? What did I do? Syntax error.
Unexpected. Expected operation expecting a talk ID. Okay. What's a talk? Obviously, these are high quality engineering tools since it's telling us all of the things in traditional compiler gibberish.
Yeah, like the thing with Yosis is I can do um
Okay, your
select.
background that showed up there has me curious. Are you actually running Windows 11 Insider Edition?
No, no, it's Fedora. I just love
Oh,
that
okay.
wallpaper.
You just put the background image. All right, that's fine. I was curious. I wasn't sure if you were doing something crazy like
Fine.
running Fedora on top of WSL2.
Not mad. LEDs and R. Ah. Okay.
Mm.
True.
Trying to see if I can
Expect
find.
from.
Since we're mostly mumbling at each other, let me see if I can find some actual music this time. Did I try that? I did try that. There was a lot of. Let's try. Let's try this. I have hopes. It might be good hopes. It might be bad hopes, but I have hopes. Yeah, I think this will work. This is approaching Nirvana's album that it just took Evolve. So yeah, there we go. It's something. Hopefully, it's not too loud. I did lower it even more.
I'm doing some weird changes here just to
It's
trademark.
kind of loud for me. But I think it's okay for everybody else. If it's bad, say something in chat, please. Nice of Yossis to put out a giant uh, license message every time you invoke it. That's not annoying at all.
Yeah, I'll try to do the LED stuff their way. I was trying to oversimplify it.
Okay.
So instead of
So you basically have to map all of the I/O pins to names and what their functions are, and then you can start doing stuff
yeah,
with them.
but sometimes you get stuff like very different ways of um, assigning LEDs
Hmm.
with where something like this just doesn't make sense. It shouldn't be the case, but I don't know why they're doing it. So
I'm battling mixers here on my side.
so usually it's just an output pin.
Okay. V15. Oh, it's not worried about your. It's not worried about that. That part's fine. The problem is line 15. It's complaining about your flag less than equal to key.
Okay.
Unexpected. Okay, so that makes more sense.
Oh,
Unexpected operation less than equal to.
wait. No, no, no. It's not that operation. It's a shift operation. So it's shifting value from the key bit to the flag bit. It's a non-blocking equation. But the problem here is it's been time since I've written Verilog, so
And it's a completely different way of thinking. No, it's all good. I was just
I think send always or
the fact
just
that the error
end.
says, yeah. Hey, that looks better. So despite us saying that the logs are terrible, it actually turns out it's fine.
I might have messed up the LED bit again, so we just go what I did earlier and hope it does not complete. Please don't complain. I'll be so happy. Did not complain. Ah, look at that. Wait. Let me just. So
Is it all blinky now? Oh, look, it's blinky.
it's blinky from
Excellent.
my
You push the
output.
button and the light turns on. Through a tremendous amount of Verilog. That's always the thing that makes me laugh about the blinky demos is that people are like, look, I push the button and the light blinks, and I'm like, yes, I've
Wait till
made
you look.
LEDs blink
look
with buttons
so,
for years. And it's like, no, but there's all this
so
Verilog in between. It's like, oh, okay.
so the best part with this tool set is you can actually see the bit stream. So take a look at this.
Oh my.
Ah,
Oh, that is a
that,
lot of hex. Actually, is it even hex? No, it's binary. It's an
no,
actual bit
it's
stream.
binary.
It's
Yeah,
actually
yeah.
binary. Wow. That's special.
It's
That's what that is. That's
like
special.
minor differences.
I
Most of
also
it.
love how on your 16 or your 21 by 9 monitor, it still doesn't fit a single
Yeah.
line.
No,
Like not even close.
I so I have to reduce it
Oh
to like
god. Oh
this
god.
level. And now you can like read it as a ROM file while all of this area is like empty, and like these are
Yeah.
this little area right there has all the
Yeah.
differences, and like this area. So it's like looking at like that SRAM die shot. Not even
Yeah.
SRAM, like the EEPROM, the CPU ROM die shot where it's like teeny tiny.
Well, I'm
You can see the
I'm
boot
willing to
code
bet that if you
areas.
actually go, yeah, if you actually go and do more with the FPGA, those other things will probably change, because those are probably
Yeah,
other columns of different types
actually,
of
we
gates.
we can compare that. So let me make sure that it somehow fits. Um, I can go into the uh-huh. So this is the LCD example. It has a lot
Oh,
more
yeah,
logic.
that's probably gonna have a lot of stuff in it,
Uh, we can do a SOC or we can do nano LCD. Let's do that first.
or not.
No, 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 no. Wait. Okay, okay, okay. It's the other way around. Nano LCD dash tang nano dot fs. The target.
I too am planning on virtually making LEDs blink this weekend. So we finalized part of the design for some of the hardware we're working on at work, and uh, one of the things that we have to do sooner rather than later is make the LEDs blink, because that's what our CEO has committed us to, and that's fine. Like, it's a perfectly valid test. Like, I'm not at, oh yeah, look at that, look at all those interesting things happening versus a whole bunch of zeros. Yeah, you can even scale down twice as
Oh,
I'm seeing it on mine,
no.
because like it's, but you can
Yeah, so
actually see
there's a
that there
lot
are some differences.
more. Let's see if I can. Um, uh, yeah, there's a lot more noise in between here where it's all
Yep.
zeros right there, and it's still
Yeah, that's all.
warping to
That's all
two
the
line.
fun stuff.
Yeah, so if I make it one line all and still visible, so this
Yeah,
is all the busyness, and then
yeah.
that is the
Those are all the different logic
yeah.
gates, as opposed to what you're probably doing is probably just like straight I/O logic gates, which is
All
why there's
right,
so little of
so
them being used.
let's try one more thing for sake of
Okay.
entertaining people on the stream.
Or just entertaining us.
Basically, and hoping that people get entertained in the
So in any
moment,
case,
right?
we have lights. We need to make them blink, while you're futzing with that. And so my what I did is I went into the schematics, found the LEDs and the part numbers. Also, I learned of a wonderful thing this week, which I had not actually delved into, but like we're the tooling that we're using at work, because we're dealing with really complex stuff, is more than KiCad, which is fine. Um, but this particular tool, it's Altium, uh, integrates with Octopart, and
Mm-hmm.
oh my god, um, I I didn't understand the benefit of Octopart until I was,
So
what was
I
that?
can't do what I want
You can't do what you want. Okay, I'm sorry.
because it
Um,
crashes.
oh.
Maybe one day it all works.
So the joy of Octopart is that you put in the part number, and then it tells you what distributors have it and how many in one place. So it will give you the equivalent part numbers for like Mauser and DigiKey and RS and a bunch of others. And I was like, oh, that's awesome. Um, and the only complaint I have is like the links of the data sheets don't always work, but it's usually pretty easy to start from there. But it was nice because I could find like, oh, hey, I can get these parts from Mauser and DigiKey. and at a glance see who had stock, because my first world benefit of living in Austin, Texas, is that if I buy anything from Mauser, I usually get it next business day, because Mauser's in Dallas, so it doesn't matter how I ship it, I get it the next day, which is nice, except that like Mauser's parts are just terrible. So I tend to prefer using DigiKey, but like getting stuff from DigiKey takes like 3 to 5 days, which is fine. But this made it super easy to go, oh, I can get all the stuff that I want from Mauser. So basically, we bought these surface mount side emitting RGB LEDs. They're not NeoPixels, they're just straight RGB LEDs, so no level shifter or anything like that. And then there's this NXP part that they found that will do PWM control and all that fun stuff. And it's automotive rated, which is interesting, and there's reasons for that are not worth getting into. But it basically just means that it's freaking huge, and it has a massive ground pad on the bottom of it. So my game plan for this weekend is to try and design a board to basically turn that and 4 LEDs into a feather wing, and then put that on top of the Blue Fruit BLE feather wing, which has the Nordic NRF 82450 processor on it, which will run CircuitPython and various other odds and ends, and then we can actually program and debug this I2C SM bus LED driver part, and make all of our lights blink on our logo, which is going to be on the front faceplate of all of our hardware. And then our ODM will be happy because when they start building the hardware, you can be like, you can run this code and the lights will blink. I'm like, oh yay!
Blinky.
Blinky.
We are happy when Solid Run, not Solid Run, the Seattle does its little dance at the booth.
Yes. Yeah, I have big plans. Since we have 4 LEDs and they're full RGB, I have big plans for stuff that we're going to do with them. Some of my coworkers are like, we want a Cylon mode. And I was like, well, of course. But I just need to figure out, like, I told them it's probably going to do Cylon while it's checking all of the memory, because there's so much memory. But as long as it's still moving, like stuff is happening, is kind of my game plan. So we'll see how it goes.
Should it be the other way around? Well, I did have one
look into is good. Go.
What's so special about the wire cutter you posted?
Oh, it's not a wire cutter. Oh, you don't know about the God hands. Oh, oh dear. So they're too far away for me to grab them. But that's fine. Basically, these are not wire cutters. They're for taking parts for a plastic model off of their runners, and they're like specifically designed specifically for doing that. I'm getting into Gundam again. It's a dark, dangerous path of lots of plastic pieces clicking together and possibly painting. I have an entire there's like several YouTube channels that I subscribe to. There's this one guy who's great. Potan Creates, Potan. He does Gundam model assembly as ASMR videos. They're very well done, and his work is amazing. Like, he's one of these guys who will, okay, I bought 2 of these ridiculous $300 Gundam models, one of which to assemble and the second one to customize. So I'm going to custom paint everything. Oh, it comes with stickers for putting in different colors. Screw that. I'm going to mask everything off and properly spray paint it. It's a good time. I have a few Gundam models that have been sitting here doing nothing, and a bunch of people that I follow on Twitch have been getting into it, and I was like, okay. And those God hands had been sitting in my things to buy later Amazon list for a very long time, and I got a couple bucks for my birthday from the aunts, and I was like, it's time. This is a path that leads down to darkness, but it's time. So yeah, Um, one of the loading ready run streams, one of the Tinker Tailor Solder Fry streams from like 3 or 4 weeks ago. Beige was over at Ian's house, and Ian, of course, has God hands, and Beige was like, I don't understand, and Ian was like, oh, here, let me show you. Like, so I handed him like he handed him one of these, the blue handled ones that we all have. Um, the ones I have some red ones that are actual wire cutters, so they're a little more heavy duty. But you know what I mean by the blue handled ones. And he picked to that, and he just cut a piece of a leftover runner. And he's like, okay, yeah, I know what that's like. And he's like, now try this. And he picked up the God Hand, and he like went and cut it. And he was like, oh my God, I understand why you spend $60 on these things now. So that kind of sold me. I knew they were good. I didn't know how good. Now I have an idea. So, all right. So we're running short on time.
Mm-hmm.
What is the thing that you are trying to do at the moment? And we'll see if we can at least get that. We'll get that done. I hope. So you just programmed it in SRAM for something.
How much time do we
Is it
have?
still 2 minutes? But we can run late. Like, it's fine.
All right. So I have to start a tick, and that
Okay.
thing will. So we make a large enough register, right? Just straight up go for a 32-bit one because why not? Oh, I deleted the wrong one. We can optimize when the time.
And this is just going to be like a tick counter?
Yeah. So it's a tick counter for as long as the key is high.
Mm.
And we can just keep adding one. And the way we can simply do is um okay, that runs once. Create another always block and go posage. Clock, and we'll need a negative edge clock as well, but let's just see.
Oh, no.
Stop.
I was going to look up this YouTube channel so I could post a link to it in chat, and there YouTube was like, "Hey, Ryan Reynolds posted a video." I was like, "Oh no," and it's entitled "We Tried to Fight Gal Gadot." It's another clip / trailer for Red Notice that comes out in November on Netflix. First line of the description is, "Spoiler alert: we lost." Here is the link to that YouTube channel for the ASMR Gunpla, which is excellent. I highly recommend checking it out. I'll even send it to you directly. And since David was talking to me on the Discord as well, I guess the next thing that we have to do over the next 2 weeks is put together a Discord server and then tie that into Twitch chat. All of that jazz, which I know can be done, but I haven't done it, so we'll get there. Uh-oh.
I
Does not
do
like your
remember.
token primitive.
Yes. I think it does not like this. I do remember doing like a combined clock, which basically means that every time the clock ticks and the key is high as well, it will run this state. Maybe I have to add like pause edge again. I'm sure like one of my like one of my Verilog stuff has it somewhere. Okay. Okay. Eh, That's a single passage with the counter. Same here.
So the single pause edge with the counter basically means that every time the signal goes high, it's going to increment the counter by 1.
Yeah. Now and we need to track two counters now.
So we need one for raising signal and one for lowering signal?
Oh no
Or
no
one for
no.
positive edge and one for...
One is like an enable wire. The other one is actual count wire. So the key becomes the enable ish wire where it goes. No, the clock becomes the count wire and the key becomes the enable wire. So every time the key is high, it clocks. It counts the clock. And we are going to slow that down later on. But thing is, dual edge is that the one?
I guess we'll get
'Cause I
through
think
this, and then we can call it a week,
yeah.
which is fine. I'm not upset, man. It's all good. We made content. It's the
We
important
did.
part, right?
Yeah, and we'll smooth it out. Dude, that shit used to work.
Oh, that's how you bring up the terminal. Oh, and it does indeed bring up a terminal. Sweet.
So this is the solution I'm seeing. People have done it with OR a lot. Yeah. So it at least sees OR as correct.
So I just told BOS to shut down. And I'm going to switch to the screen quickly because you're going to love it, Sahaj. You are going to love what it has done.
You have asked who to
Behold.
shut down?
I asked BOS to shut down on the excuse me, Haiku to shut down on the Sci-Fi,
Uh-huh.
and look at the screen it's given me.
I see system is shut down. It's not safe to turn off the computer.
How long has it been since you've seen a screen that says it's now safe to shut off your computer?
Yes, it's been a while. When did I last run Windows um,
Windows 90, whatever. Yeah. Here, I'll wait until you get all
98
your
had
browser
it?
windows out of the way before I transition back.
Yeah,
98 or the Millennium Edition.
I have never run that.
Consider yourself lucky.
Or we can just do the simple way of.
The simple way.
Okay, so this should track, and then we can have talk to track the other thing. And we can add a stupid logic to check if our thing's correct. Let's go bit 24 and nope. Four. Oh, seems right, right? All right, so that's a very basic bit of that logic working.
Okay. Oh.
Um,
Okay. Yeah.
I've
So
I
all the
have
green is on and it's pulsing the blue. Some other LED. Doesn't matter.
no. So blue and red are on, and it's pulsing the green. That means it's in talk
Ah.
mode, and the key is down. So it's counting the lower edge. Um, but if the edge is high, then the green one is flashing. So so this is
Yes.
basically counting for how long that edge is high, and if I sort of reduce the so it goes from LSB to MSB, and you can if I lower the bit value here, it'll count faster because the LSB stuff moves faster. So if I go to something as low as 20, it'll go should go crazy. Might not be able to see it, but if that, then we can increase it. Yeah, well, so
Oh
that's
yeah.
sticking, and
Mm-hmm.
that's barely visible, but
You can kind of
that's
see it. Yeah.
So we count these pulses, put it into a register, and that gives us our
The camera
RPM
does not
because the
like the
faster
flashing
I do,
green.
because the faster I do, the less amount of ticks there are. So
Sure.
that's the basic logic we are going to do. Had I not
Cool.
had the plans, it would have been done.
It's
But
okay. Like I said,
uh,
like scheduled things happen. It comes up. Like I get it. Like sometimes people interject. It's not a big deal. So cool. All right. Well, I think we can call it here for now, and then I'm doing something in 2 weeks. I haven't figured out what yet. But that's the current game plan. In the meantime, I will. I'll see if we can get ourselves a Discord. I will link it on our normal site, which is hang on a second. Let me go switch this over to things. Here we go. Um, I'll post it up onto the site, which is benchfreq.link. And that will be a way to get into the Discord. We'll talk about it on some of the Discords that we're already on, and then other than that, we'll see everybody in 2 weeks. And as always, feel free to reach out to us on Twitter, shoot us emails, all that jazz. We're happy to engage with everyone, and obviously on the various Discords that we're already on, and we will be on more. We'll have another one for this whole thing here in a couple weeks, hopefully. All right. Have a good week, everyone. See y'all later.
all right, bye.